Hola clase. In some previous videos we just seen what is a derivation. What am I searching for? And we've come to, yep, it's finding the gradient of the line that is tangent to a function, and we came to something called differentiation by first principles. That is an equation that allows me to find that answer, that derivative. Now, you're going to be thinking, okay, but how do I use it? And for that, we're going to use a function, something easy, something that we are used to. X squared, we've seen that 100 times. We know how it looks. It's a parabola, and we know to any of those points, I will be able to attach a tangent, and that line could have a gradient. Now, what is the function of all those gradients? That's where we use this. And for that, we need three parts. We need f of x. Well, they are giving me that, so no problem there. X squared. I need f of x plus h. And if I've got one, I can find the other. Wherever I find an x, I change that for an x plus h, and everything goes the same. And I need h, which I'm defining. I know it's tending to 0, so I can put there. Alright, with all these pieces, now we're going to go, okay, if f of x, the function of x squared, f prime of x is what? The limit when h tends to 0 of some quotient. Which one? That's where I begin putting the things. First, f of x plus h. Okay, it's that one here. So in this case, is x plus h squared. Okay, minus second part, f of x. Okay, is this one here. So x squared, h. H is h, that doesn't change. Okay, now what I've got is from the general equation, I've got the one specific to this function. And now I can begin operating with it. Let's see. I've got a quotient, I've got an x there, an h, I've got an x squared. This, well, I've got here a binomial. This is the same as if I could be x plus y squared, and that I can expand no problem, and I know that is not x squared plus y squared, and I know you know too, that's why I'm not even mentioning it, so we can expand. Okay, I'm going to leave it in brackets so we see where it's coming. Everything else staying the same. Expand this, x squared plus 2xh plus h squared. Everything else I left untouched, so I carry. And now I begin seeing terms that I will be able to cancel. I've got an x here adding, an x here subtracting, so what am I left with? Again, limit of h tending to 0 of 2x, and I see an h there, plus h squared. That means I'm going to be able to factorize here. And that's useful because now I can simplify that quotient. What am I left with? Limit of h tending to 0 of 2x plus h. And remember, all of this is because we're searching this f prime of x. Now, how do I work with this limit? How do I see what this is tending to? Now it's when I use this. H is tending to 0. So to all effects, h is a 0 unless it gives me trouble. So this it's going to be very, very close to 0. So 2x plus h. When h tends to 0, it's going to be what? I can eliminate that. 2x. That is the answer that I'm searching for. So now I can go, mark it as my answer, and say, alright, if my function is x squared, f prime of x, the derivative of that one, using what I know, derivation by first principles, is 2x. And this is how I derivate by first principles. This can change. This can be any function. Doesn't matter which one it is, I will be able to use my derivate equation, or my derivation by first principle, whichever you prefer to call it, and get to an answer. I hope you found that instructive, so thanks for watching.